Okay, in this question, they give the equilibrium constant, which is equal to 0.11. They give the balanced chemical reaction, and it asks to calculate all the equilibrium concentration if 0.33 moles of ICl is placed into 1 liter vessel, and the reactions are allowed to reach equilibrium. So what I did was I set up the chemical reaction above, your equilibrium constant, which is 0.11, our initial concentration of ICl, which is 0.33, and we derived that by dividing the given moles, which was 0.33, divided by 1 liters. And since the initial concentration of the product is 0, the products are going to, let's try that one again. It's going to gain in concentration, and the reactant is going to lose in concentration. So we set that up as 0.33 minus 2x, x, and x. And when we set up the k constant expression, k will be equal to always the products, I2, multiplied by the other product, divided by the reactant, ICl squared, because whenever you have a coefficient of whatever the coefficient is, it becomes the exponent of that entity. So we're going to substitute all the values. So k is 0.11 is equal to, well, I2 and Cl2 is x, so x times x gives us x squared over 0.33 minus 2x squared. And to get rid of that squared, we're going to root both sides, okay, which gives us root of 0.11 is equal to x over 0.33 minus 2x, and which will give us 0.11 times by 0.33 minus 2x is equal to x. That will give us root of 0.11 times by 0.33 subtracted by the root of 0.11 multiplied by 2x is equal to x. So we put everything onto our x variables onto the same side, so that gives us the root of 0.11, 0.33 is equal to x plus the root of 0.11 2x, and let me just plug that into the calculator, see what the values that I get. So we have, let's see, the square root of 11, the square root of 0.11 times by 0.33 gives us about, I'll write it here, 0.109, and I'm not going to write all the decimal place, and x plus, let's try that, so square root of 0.13, no, sorry, 11, square root of 11 times by 2 gives us 0.663x, and let's try to simplify that. 0.109 is equal to 1.663x. We're going to divide both sides by 663, 1.663. So when we plug in the calculator, 0.109 divided by 1.663, which gives us 0.0554, and we round that off as 0.066, we'll say moles over liters. Okay, and that's the value of x. So the concentration of I2, iodine, and chlorine will be 0.066 moles over liters, and that of iodine chloride, ICl, will be 0.33 minus 2 times 0.066 moles over liters, which will give us, let's give this a try. 0.066 times by 2 and subtract, which gives us 0.198, and we can round that off as 0.20 moles over liters for iodine chloride.